Okay, so we're going at 1. Not a case of mistaken identity. Exploring polynomial identities. Warm up. Expand or factor each expression. Alright, let's take a look at number 1. So a plus 3 squared can be rewritten as a plus 3 times a plus 3. Okay, we're going to multiply using the box method. So a plus 3, a plus 3. So a times a is a squared. A times 3 is 3a. 3 times a is 3a. And 3 times 3 is 9. So this simplifies to be a squared plus 3a plus 3a is 6a plus 9. All right, go ahead and finish up number 1. All right, let's take a look at number 2. Now, number 2, we're going to factor. We know x squared, so we know 2 parentheses. And we're going to factor using the reverse box method. So first term is a squared. Last term is negative 25. Since there is no middle term, these two combine to be 0a. Okay, so to get a squared, we know a times a. And then we need to figure out what number is multiplied to give us negative 25. Well, that's easy. That's plus 5 minus 5. So a times 5 is 5a. Negative 5 times a is negative 5a. 5a minus 5a is 0a. So this works. So our factors are a plus 5 and a minus 5. All right, go ahead and finish up number 2. All right, let's take a look at number 3. Now, a minus 8 squared can be rewritten as a minus 8 times a minus 8. We're going to multiply using the box method. So a minus 8, a minus 8. A times a is a squared. A times negative 8 is negative 8a. Negative 8 times a is negative 8a. Negative 8 times negative 8 is positive 64. So then we have a squared. Negative 8 and negative 8 is minus 16a plus 64. All right, go ahead and finish up the warm-up. All right, let's take a look at the next page. Make it or break it. The student works 1A, 1B, 1C, 1D, 1E, 1F, and 1G. All right, go ahead and mark out the remaining questions on this page. Let's take a look at the next page. 1.1, calculating with polynomial identities. You have learned about many different equivalent polynomial relationships. These relationships are also referred to as polynomial identities. The polynomial identities you identified in the Getting Started are shown. Polynomial identities can help you perform calculations. For instance, consider the expression 46 squared. Without a calculator, you can calculate the value by using the standard algorithm for multiplication. You can also use a polynomial identity to write an expression that may be easier to calculate. All right, go and look over the worked example. All right, let's take a look at the next page. Go ahead and mark out this page. Activity 1.2, generating Pythagorean triples. Remember that a Pythagorean triple is a set of 3 positive integers a, b, and c such that a squared plus b squared equals c squared. 1. Determine whether each set of numbers is a Pythagorean triple. Explain your reasoning. Well, this is a, this is b, and this is c. These numbers are not a Pythagorean triple because 4 squared plus 5 squared does not equal 9 squared. All right, let's take a look at b. These numbers are not a Pythagorean triple because they are not positive integers. All right, let's take a look at c. Again, this is a, this is b, this is c. These numbers are Pythagorean triple because 39 squared plus 80 squared equals 89 squared. All right, go ahead and mark out this and this. Let's take a look at the next page. There is an effective method to generate Pythagorean triples that involve a polynomial identity called Euclid's formula. Euclid's formula is a formula used to generate Pythagorean triples given any two positive integers, r and s, where r is greater than s. Euclid's formula is shown. The expression in Euclid's formula represents the side length of a right triangle A, B, and C as shown. Go ahead and read over the worked example. And then go ahead and mark out 3A. Let's take a look at the next page. All right, the teacher works 4A and 4B, and the student works 4C. 4. Generate a Pythagorean triple using each pair of given integers and Euclid's formula, which Euclid's formula is r squared plus s squared squared equals r squared minus s squared squared plus 2rs squared, where this is r and this is s. Okay, so we plug these numbers into this formula, and we have this. And now let's go ahead and calculate those numbers. So first off, we have 7 squared plus 4 squared squared is 4,225. Equals, now we need to do 7 squared minus 4 squared squared. So 7 squared minus 4 squared squared is 1,089. And then we need to plug this into the calculator. So 2 times 7 times 4 squared is 3,136. Okay, now we need to see if this statement is true. So we have 4,225, and let's see if 1,089 plus, so you can see that these are equal. This checks, so this is an example of a Pythagorean triple. All right, let's take a look at B, where this is R and this is S. So we plug these numbers into this formula. And let's go ahead and clear out our previous problem. So we do 11 squared plus 5 squared squared is 21,316 equals 11 squared minus 5 squared squared is 9,216, and 2 times 11 times 5 squared All right, and let's check to see if this is true. So we have, and let's see if that's equal to 9216 plus 12100. These are equivalent. So this checks. So that is an example of Pythagorean triple. All right, let's take a look at C. So C is, this is R, this is S. So we plug these numbers into this formula. So that's 20 squared plus 15 squared equals 20 squared minus 15 squared plus 2 times 20 times 15 squared. And you can finish that question on your own. And go ahead and mark out 5 and 6. And have a wonderful Wildcat day.